Miss Griggs, what are residuals? Well, I'm going to show you. Residuals are vertical distances from a single point to your LSRL. So, here's what I mean by that, because a lot of students have a freak out attack about this. Okay, so let's say I have my scatter plot here, and the LSRL that's produced from it looks something like that. Okay? Well, each of the ordered pairs, some of them, see, are really close to the line, and others are kind of not very close at all. So this is my LSRL, okay, and we write it as Y hat. This is this little symbol above Y. That means it's a predictor of Y. So when we write out our LSRL, we're going to write it in context with that little hat above it, because in math that's a symbol for a prediction. Okay, so what is a residual? Well, practically speaking, if you will look at each of these ordered pairs. So this ordered pair, oh man. Okay, I fixed it. Okay, so our ordered pairs, see this one and this one and this one are pretty close to the line. So the way I've drawn this, you're not going to be able to look at how big the residual is. But these other values, okay, each of these that I've drawn, each of these vertical distances, those are all known as residuals. So those are residuals right there. That's what those look like. All right, so what does that mean to us? Well, let's look at, I'm gonna make this a little smaller. Okay, let's look at this ordered pair right here. All right, this is X, Y. Well, along this, down here on my actual LSRL, there's a Y value associated with this Y value up here. The X value's the same because they're right in line with each other. This is a vertical distance. So if I want the residual, that means I want to know the distance between my actual data point and the Y that corresponds to it along that same X path on my LSRL. So how do I find that? Well, mathematically, I just use subtraction, and that is going to give me my residual. By the way, if it's above the line, if it's above the LSRL, it's going to be positive. If it's below the LSRL, it's going to be negative. So that's how you find a residual by hand. You can also type y equals whatever into your calculator, and you can trace. You can use a trace function to find your residual value. There's all different ways that you can do that. But we are going to stick with how to do that in the examples that I'm going to show you. More than likely on your AP test, they will give you a residual plot, and I'm going to show you what that looks like. So a residual plot just means that it has taken all of the X values and it has paired them up with your residual values. Now, a residual plot is not going to look the same as the scatter plot because your residual plot pairs your X values with those vertical distances. So even though you can see the distances with the scatter plot, the residual plot is special because now it's graphing your vertical distances, not your XY points. So it does make it a little bit different looking, as you can see in this picture. So this straight line here acts as the X-axis, or you can think of it as your line just kind of flattened out so that you can see the vertical distances more clearly. So what we want to see in order to determine if a linear fit is actually a good fit for our data. So let's say we're given data. All right, I find the LSRL, I find the correlation coefficient of R, whatever it is, I find my slope, etc., etc. Well, why do I need the residual plot? Well, the residual plot gives me a good understanding to see if a linear regression is actually a good fit for the data that I've been given, because sometimes it's not, even with an R that might be close to -1 or close to +1. The residual plot just kind of lends a little bit of certainty to knowing if a linear regression is a good fit for your data. So what we want to see in a scatter plot, we want to see something that models a relationship of some kind, some linear relationship. So we want to see pattern in our scatter plot in the form of a line pattern. That's what we want to see in a scatter plot. But what we want to see in our residual plot is a random scatter about this axis right here. Because when you straighten that out, if you see a pattern in your residuals, that indicates that a linear regression might not be the best regression for your particular data set. So let me show you what I'm talking about. Residual plots that indicate a linear model is a good fit, something like A right here, all of that scattering of all of those points, that is a good fit. That means the linear model is a good fit for your particular data set. This, not so much, and this, not so much. Because as you can clearly see in B and C, we don't have a random scattering of our residuals. Our residuals here look like they're linear, and our residuals here are clearly in a curve pattern. So these are not data sets that are a good linear fit, but A, that's what we want to see in our residual plot. We want pattern. In the scatter plot, but we want random in the residual, okay? You have to separate those in your mind or you're going to get confused. Heads up.